Alright, okay. Let's go ahead with what we're doing. Alright, so for today's one, we're doing more of floating point unit instructions. Let's just go to my GitHub real quick. Yeah, probably gonna miss today. That's fine. No biggie. Let me get my chat set up properly so I can see the chat. All right, there we go. All right. All right, so last time we actually did. Let's actually move down here. All right, so last time we implemented float load word and float store word, and we implemented the memory for it too, the registers, floating point registers, so writing to floating point register and reading from it, and also in our header file we correctly added to our struct the array for the floating point registers. So yeah, that's pretty much good there. So now we need to actually implement some of these instructions here. We did these two so far, so now we need to actually move on. So let's start with float add word. All right. So it's a bit different here. It's a bit different here because no instruction we have like resembles this at all. Like destination register, register source 1, register source 2, that's fine. Stuff mimic that, but it's the rounding mode part at the end that's kind of different. So let's do a little query. Let's understand what is going on there. So setting this one, there is no current any integer because there's no running mode is new, set bits 14 to 12. As you saw, the 3 bits. Same position functory, so existing functory get extracts already, just with a different semantic meaning. I see. So I wouldn't need a specific running mode instruction. Not running mode instruction, running mode. Sets that running mode. What was I gonna say? So although I will be using what was I gonna say? Okay, although I will be using a separate struct, not struct, bro. Separate meaning and obviously meaning. I don't know the word for this honestly. Meaning in both this is the instruction typed in because there is no equivalent print for main. Yo, what's up, Exo Studios? Welcome back, man. New combination of games mixed in the new game. Nice. You said earlier on Discord that you're gonna you're making a new game. Yeah, I remember that. So what's the combination of game that's being made? Alright, so new branch. Yeah, that's fine. I'll do that. Yeah, okay. Cloud keeps giving me code for that. Like, I know how to do it. I just need your answer. You don't need a function right now. You don't need to accept it all for a basic floating point implementation. If you want to implement it properly later, you'd use fset round from CF. Supposed to set the host floating point unit rounding mode before each operation. But that's a future concern. Alright, we'll do that later then. If it's a future concern, let's just do what we've normally been doing. If it's nothing new, I think we should breeze through this pretty quickly, to be honest. Maybe like today and tomorrow, and probably be done with floating point, then move on to double. Okay. So we want a new one in here. So after Jalar, I'll say, what should I call it? What is he calling it? Just floating point? Let's actually take a look. So for these follow that same procedure. These change a bit. So I'll call it maybe I'll call it floating point arithmetic instead. That might be a better version. So okay, let's see how many different types we need. So there's going to be a simulator one, and there's going to be an obby one mixed in, and a mini games one mixed in. What's the simulator going to be about? Do they like tie in together, the simulator and the obby one? Like, is it going to be like a bunch of mini games mixed into kind of like a simulator game? Let's see how many different types we need. So these follow the same path. This slightly changes, so we need, alright, so we need one, we need, this one also slightly differs, these two. Might be better to do a stud map, but I might do that later, to be honest. Okay, so we need 1, 2, 3. This also changes, we need 4, 4. Okay. Let's just call it floating point arithmetic for now. FPA. It's a kind of a bad name, but we'll fix it later. Gonna add a laser battle one too. Nice, nice. And then the name, we'll store it like under here. Call it FPA. And make our separate ones. The first one we're gonna implement is fpad. So fpad. All right, that's the first one we're gonna implement. Let's go, and we need to also implement it here too. We need to add it in here. So instructing the string. I need to do it here. Under here. Let's do it under here. And call it floating point. Oh my gosh, it's like a topic today. Arithmetic instructions. I mean, maybe, man. I usually just do my coding on these streams, so maybe it depends. I just do my coding alone here. I might prefer to just keep it like this, how I usually do my streams, but we'll see. Alright, so we're gonna call it same as earlier, so PA. Not FPA, it's a specific instruction. That. And then turning that value. Oh, I thought add that S, sorry. Should update that actually. Are we not able to actually do that? I guess, yeah, the dot is not able to do that. Let's just call it FAS. We don't need the dot. But like in the actual thing, we'll have the dot in the string. Yeah, I don't know if I'm too interested in the collab right now, but I'll let you know. Alright, that should be fine here. Okay. Alright, I think, yeah, that's actually implemented here. I think one of these streams we're gonna have to clean up all this, like make it like a std map instead. Make it easier to access all these. It's pretty easy right now, but it looks kind of cluttered, but we will fix it one day. For now, we'll keep it as this. This is working fine. I just recently learned about std maps, std unordered maps, so we'll see what we can do there at some point. But for now, oh, pinned it accidentally. Alright, for now, let's just do this. So we need to go in here. Let's do it on this one, yes. So let's see what like these instructions are. So for fadd we have gonna probably be working for the rest of the week, working on your game. So even within these instructions, they overlap a lot. Like fadd, oh my god, I thought that s and s square root are different, and the variations are like 6 of them probably. So in the email class I PA I don't know. Okay, so it doesn't really matter. Why AI? I'm here to learn. Yeah, I'm just using it for simple stuff. I'm not really using it to like code too much. Only like if I don't really understand something. I'm just using it for explanations. Alright, so if it doesn't really matter, I guess we can just go on with it. Alright. So let's go back to fadd. The opcode here will be, let's try and get that opcode in hex. So what was it again? So 1010011. And that will be 53 in hex, so opcode is 0x53. And we don't have a func3, but essentially it's similar in a way. It's just going to be, well, we don't have a specific for RM for the rounding mode, do we? Let's see. After instructions risc-v. I noticed I know you noticed that I got hacked when I changed my account password. A small Roblox game dev, the most thing that I want right now. So I'm going to make a new channel and talk about my lore. I'm making, because I have this entire kind of thing for lore. Yeah, that'll happen once, like, if your game gets out there, that'll happen. Then like YouTubers will get on it. Okay, let's look at the doc. And specifically go to fadd.s. Yo, what's up, Casey Mans? Welcome back, man. Okay. Wait, they do have they do change a little bit. Oh, they have an FMT. All right, wait. So we probably should change our function a little bit. Implement a new one. So I guess we can go in here. No, we'll stay in our decoder. That's in our decoder. We have to make a new function here. So we unzip it, and we'll be getting the bits for FMT. So we'll call it get FMT and passing in the value to grab that. Do you stream every day? Almost. I try to. Sometimes it gets too much and I can't. I usually stream around this time, but I can stream earlier if needed. If sometimes I feel like streaming earlier, I can. But usually around this time, it's 11 p.m. for me. I didn't notice I got hacked because I don't know if I sent you the message, but I said that I was making till ice cream. How'd you get hacked? Like, did you click on anything? Like, click on any links on Discord, even if it's from like a trusted friend. Sometimes like it could be wrong. All right, so get FMT. So we also need a func5 function too. I didn't realize. Okay, so I'm just gonna copy this. I don't want to write the entire thing. All right, so for getting func5, this takes up upper bits 27 to 31, so it's gonna be around a 5-bit shift. So we can why is it caps? So func5, that will be equal to the value right shifted by not 5. It would be 27. Sorry, 27. It'll be shifted right by 27. So these bits occupy. These bits are shifted all the way here, so we can immediately grab them. And there's nothing to the left of it, so we can just call it there. Oh my god, I keep capitalizing stuff, sorry. And then return func5. we don't need a mask, but I guess it's always better to do a mask. Just in case the implementation changes in the future. So yeah, might as well do a mask. So it's the 5 bits, so it'll be 0x 1f. That should be the mask. Right, and then return that. And then for FMT, so it's gonna be a value, and let's see. So it takes up 2 bits, 25 to 26, and we need to shift 25. It's the right to get it to 0th position. 15 by 25, and here's where the mask actually is important, because when we shift these, we're also shifting these. So we'll shift them over, right? But we need to mask these. We don't want these, so we want to mask them out. So it will be a mask of 0x something. Wait, 0, what would it be? Let me see what it would be. Binary. So it'd just be like 30 of these zeros, and then 1 1. So 0x3. Yeah, 0x3. I could have got that without looking at that. And then 0x3. So now when we actually shift these bits, the funct5 will be masked out, so it won't interfere with the FMT. So we'll solely be grabbing the FMT. Actually, is FMT 0 for everything? If it's 0 for everything, we don't really need a function. I didn't realize. Let's just make sure it's 0 for everything. Okay, if it's 0 for everything, we don't really need it. We'll always just be writing it as 0x0. But I guess it's good as an identifier, but I don't know. I think it's good to have as an identifier, but I'm not really sure we need it. I'll just keep it here for now as a placeholder. If we need to get rid of it, if it's redundant, I will get rid of it. But it looks like FMP is 0 for everything, so yeah. I noticed that when a bot goes in an account, it targets the small servers instead of the large and big ones, and it unblocks people that you have blocked and sends them a message. Interesting. I mean, usually to get hacked, you click on a link or something. That's usually what happens. It might look like a harmless link, but it's disguised as something else. So you have to always look at like the actual hyperlink, like what it's going to make sure. Okay, so we already know that FMT is redundant. So now we have our funct5, so we can get in here and actually do it. So if our opcode is 0x53, is there any other opcodes that are 0x53? If it's not gonna collide with anything, I'm just gonna check. Then we don't need a second instruction. I think it's fine. Oh, but the problem would be... Yo, what's up, Polycoder? Amazing thing you're doing. I appreciate it, man. You completed a project same during college on like this stuff, on computer architecture stuff. That's interesting, man. Interesting. How was that? Like, how was that process? Did you enjoy it? Alright, so... we need a way to distinguish. I guess the main distinguisher is their funct5, so I guess we can... Every single funct5 is distinct, so I guess we can make the condition if opcode is equal to 0x53, we can make it and funct5, and I keep mistyping. I need to get into a code editor like Helix or NeoVim. It'll make it much easier. Alright, so for each one we'll distinguish by funct5. So the first one's 0x0, And wait, I forgot we did not make a funct5 yet in our variable. Five and then call it a function. Okay. Funct5. Passing the value in. Okay, now it should be good. We have it stored in now. Yeah, perfect. I'll be working a little bit, so I'll come back. Alright, see ya, EXO. Hopefully that game goes well. Okay. Opcode 0x53. And what are the fields we need? So we need rs1, rs2, rd, so oops. Okay, so it'll be similar. It'll be similar here. So let's f add s. Instruction type will be fpa. Okay. And okay, so we need rs1, like usual, rs2. We also need destination registers, so rd is equal to get rd value. And we also need fmt. Yeah, let's just get it for now. That should be fine. What's the problem? What's the problem? Decode instruction has no member FMT. Yeah, sorry about that. How have you been doing? I've been doing good, man. Got finals coming up soon, so I gotta start studying for those. Right now it should be fine. Yeah, okay, now it's good. How about you, Casey, man? How you been doing? I remember you said you were working on some physics concept or something. I forgot exactly what that concept's called. It's like some transistors thing. Got finals coming soon too, yeah. For my cyber class, my teacher makes the cybersecurity like exams really hard for some reason. I don't know why. It's supposed to be a foundations class anyway, so I don't know why it's so hard. Okay, we're good here. And we can essentially just copy and just variate now, since we got most of the logic for that part done. Put them the same. Let's see the... Yeah, I'm still learning that, yeah. Seems like a pretty hard concept. And that's also the first time I heard of that concept too, that you mentioned the other day. Okay, so we're done with that, and this will be funct5 x0x2. And it'll essentially just be the same. I think we should initialize all of these. Oh, it's not sub yet, it's more. We need to initialize them in our enum class. Okay, so here. Fmol, fsub, and fdiff. These all follow a similar layout, so that'll be fine. Square roots when it changes a bit, that changes, so yeah. Alright, so let's go back to our thing. What's going on here? Oh, okay, sorry. It was just delayed. Alright, let's go back up. We need to initialize. Yeah, I really gotta get around to making a std map because like it's not hard to access it. It just feels so tedious sometimes to do it. What's gonna be? Just make sure to change it so nothing bad happens. Small and then here. Like this. It's just all the same, right? Fmls, f sub s, f div s, yes. I'll check what this problem is. Oh. I didn't write it right. Oops. Yeah, now it should be fine. Change it here. Alright, now it should be fine. And we can implement the functions. Fls. This will also be in the floating point arithmetic. And essentially the same, so that's the same. Now we can... what's this doing here? That's a problem, yeah. Essentially the same for everything. Essentially, so opcode's the same. Wait. So, oh, that's my bad. I changed opcode. I'm supposed to be changing func too. I thought it looked a bit odd. The func 5. Yeah, this is better. And for f sub now, func 5 is 1, so 0x1, and then it will change here for f sub s. Same stuff, same stuff. Same thing with the floating point division part. Then after that, we can implement them into our floating point registers. So that will actually take a bit more time, but what is it for div? So it's 3. There's 3, and make sure we say div s. And yeah, it's fine. Now here, let's just do a quick check with Claude. Give Claude everything so far to make sure I didn't mess up anything. And I'll give it my functions up here too, that I wrote. And also, like, say, FMT, I noticed, is kind of redundant. But okay. Yeah. All right, let's give that. Few things to address. GetFMT is missing a return statement. I knew I messed up something. Okay. Yeah. Func 5 plus func 7 using bits 31 to 27 while the spec is So it's just, so we should just use func 7 instead. Okay, that's, yeah. Wait, so what's the point of that part? It matters for when you change to D. How does D? Okay, but okay, wait. Wait. You have Discord or something? I don't have a Discord server, but I do have a Discord. I can send it in chat if you'd like. Spec shows that it takes front 5 bits 31 to 37. Let's see, 47. So I thought it would be keyboard. I'm just using a random keyboard. It's called the AZA 8 ZZA. It's just a random keyboard. It gets the job done for this stuff, so. Alright. Uses phone 5. Yeah, I'll put the Discord in a second. Give me a second. Okay, so that'll be identifier. Further. I'm mistyping so much today. How old are you? I'm 19. You're right. I was wrong. Yeah. I mean, come on, guys. Claude was wrong. Admission of guilt right here. That's why you don't blindly trust AI, bro. Alright, let me get the Discord now. Let me just make sure my Discord is there. Alright, yeah, my Discord's fine. Nothing. Alright, my Discord is... Oh, it does stream remote stuff. That's my Discord, Newton App Dev. It's just the same. So yeah. I'm doxing my ID, I'm sorry. AI is always confidently wrong, yeah. I mean, I've encountered many times where it's wrong. Like, in higher level calculus, like, it got wrong many times, and I caught it, and I asked. Func5 identifies the operation. FMT identifies the format. Single, double, yeah. I appreciate you admitting it, Claude. So I was actually right to implement this. So I'm good. Did I have any other concerns though? Look correct for the basic 4. Yeah, that's fine. Alright, so we're fine with that. Now we can implement it in our here. Okay, let's take a look. That's the wrong one. Okay, so fadd.s. So we have a destination register, rs1, rs2, rm. Oh yeah, before doing that, we need to change in our main function. Forgot. So instruction type, and it was FPA, right? FPA. If our instruction type is FPA, we will input out what we need here. So these 4 instructions are formatted as the name. So name. Then they have destination register, which will be X of something. So X. This might be one of the main things I hate about C++. The output is so, you gotta do so many things to just get simple output. I don't even know if they have string interpolation in C++. Like, that's a F string in Python. I don't think they have it in C++. I might be wrong, but I don't think so. Okay, rs1. No, it's RD, sorry. RD. Here is the rs1. And then we need one more register, I believe, which is rs2. I think I saw that. Yes, rs2. So this will be X destination, X rs1, X rs2, and then rounding mode, which is, how do they like write that? Let me see. How do they write that exactly? Is it just like the number or what? I guess I'll just write that for now. Leave a space between that. I think that's fine for now. I'll revisit that if I need. What's going on here? What the? I'm really confused. What the hell? See out, right? See out. Yeah, I did it right. Oh, I messed up. This won't work without this. Totally forgot. Say your request. All right, I'll accept that in a second. That's gonna be. Alright, that's fine. Alright, so we got this. And then. Wait, no, I'm such an idiot. That's only for this because the identifier name doesn't allow that, but everything else is fine. Yeah. I forgot. I was gonna send you a leak of the new Exo Corrupted event, but I couldn't right now. Later though. What's Exo Studios? That's someone who joined my channel around when I was doing like Roblox content, Roblox dev content, but I didn't really like Roblox dev, so I guess some of the subscribers are still lurking from Roblox dev. But now I'm strictly gonna be like C++ systems programming. Hey, what's up, Just for what am I making? Essentially, it's going to be a risc-v, like that's a type of CPU architecture. It's going to be a risc-v emulator. Right now I have a decoder written. So essentially this takes in 32-bit strings and decodes that into the assembly instructions. And this one actually, for the interpreter, this actually mimics memory. So I have registers and I have actual memory set up for this to actually like interpret the instructions and put them into registers and do computations. And we're working on floating point right now. So regular integers function differently than floating point in assembly, so I have to change up a lot for stuff like that. So right now we're doing floating point. Next is double, which will be after floating point. But yeah. Alright, this looks fine. Now we can actually move back to the interpreter. Okay. Let's take the instruction and we have to do f add s. Alright, for the case of this, alright, let's see how it's actually implemented. Okay, so in a normal thing, it would take the source register 1, add it to source register 2, and put in destination register. I don't know what it does with the RM, so I need to actually figure out what it does. What does it actually do with the RM? And I don't know why I wrote that. Just type in f add.s. Is there any like notation for that? From single precision floating point addition and multiplication respectively between rs1 and rs2. In each case, the result is written to destination register. Yes. The 2-bit floating point format field is encoded as shown in the format field encoding. Okay. So how do we actually know what the rounding mode would be though? Oh, I guess one more thing we need would definitely need to be our func3. Right? We'd still need the func3. That's my bad. Let's go back down here. Or no, it'd be fine because we already have it. Getting a little confused here, but it's fine. Let's just take it slowly. Floating point's definitely a tricky one. But if I get floating point, then double should be easier. Be back soon, and also nav X corrupted event leak will be given to you soon. Alright, man, looking forward to it. Okay. I really don't see. They didn't really specify like what it actually does to the thing. So I guess we have to ask Claude because like I'm not finding the actual layout here of how it's added. But Claude might get it wrong, bro. I don't know. Which one is this? This is docs risc-v. Let's look at the deep wiki one. Let's see. What kind of opcode values are you handling? For risc-v, opcode is it takes up 7 bits from bits 0 to 6. I'll show you my thing. Yeah, bits 0 to 6, so we're basically masking out all the values except the first 7 bits. Opcodes will be like this. Yeah, I have to refactor that at some point. I'm just like using the if else statement right now since I'm just writing simple logic. I'll refactor it later though. Yo, we got 12 years in the chat. That's amazing. Yeah, premature optimizations though. Yeah, that's definitely true. I'm just working on the logic, making sure I understand everything. Then we'll refactor later if needed. Okay, I really can't find like the actual like implementation. Oh wait, it's right here. Wait, no, that's a different one. Wait, so they're not showing me like how. I guess it's just. I guess it's just the same. Alright, I will try it. Okay, so we need to write to the register, and the values we would need would be, so RD will be the first value, and we'd need our inst, we need to read the register of inst.rs1, plus x2. But then this would end up being the same as our... Oh, sorry. It'll be separate. So reading the registers of these two. But this would then be the same implementation as, it's a lot, as our regular add. So like, how does the rounding mode actually get implemented? I'm not seeing like anywhere where it actually tells me how it's like being implemented, which is kind of sad. Okay. They're showing me for this one, but this one's not the one I'm looking for. Oh, wait, here. Oh, is it really just... It's really just this. Oh, yeah, okay. But it would be right floating point register, so I guess that's fine. I think that's the implementation, I think. Okay, the answer, I'll look in a second. Bro, I'm mistyping like crazy today, dude. Holy. Alright, and then it'll just be the same. We'll just write out the simple ones first. And then check with Claude. But as we know, earlier Claude got it wrong, so I need to make sure. I need to actually like check up on Claude and make sure he's actually doing it right. Small this. And this would essentially just be multiplying. Okay, I might keep this page. This page is nice. Looks like it goes in depth more. I'll close all other pages. Okay, so for that one, we did it right. And then for multiplying, it's the same case, yes. And I need to change these two as well. Alright, and for our division one, there's probably going to be a case of divide by 0, so we probably need to write that. Let's see. Yeah, it's just going to be divide, but we probably need an if statement here and to handle the case of the... Is there actually like... What are the division cases for... Oh my god, dude. I actually suck at typing today. Floating point. risc-v. I know for integers there's a divide by 0, but what happens with floating points? I heard like sometimes it goes to like infinity or something. I'm not actually sure. They really don't have anything either. Documentation. Dude, why is documentation like skipping out and stuff? Or actually, wait. Is there no case of overflow or something? For now, let's check here. Hey, let it be known that Claude was wrong. Let it be known. Alright, so let's do a little query and then check up on the information. Alright, so this is what I have. This. Oh wait, hold on. Yeah, he's gonna call me out on that. I just realized. Alright, now we can copy. I don't want him to call me out on that, so. Alright. That's what I have for this. Is there no case? 0 case for this. I knew I forgot something. He always calls me out on something, but I appreciate it. Break statement. Totally forgot. I was gonna write it later at some point though, probably. Alright, yeah, forgot break statements. Alright, what else? On division by 0, this is where floating point differs fundamentally from interdivision. Yeah, I knew there's some different standard. IEEE 754 floating standard handles division by 0 automatically and returns infinity. Oh, so we don't really need to do any check. Actually, I'm not gonna lie, floating point actually handles a lot of stuff for me. So far, I'm not gonna jinx it. It's probably gonna have some nuances later. So yeah, I think that's fine. Those 4 cases are complete then. Now we have to check the next cases. Alright, so we got those done. Now it changes a bit because so far it's like this. The layout of bits is different, but the identifier needs to change because now we don't have an RS2. So I'd need to change it slightly. So let's go back to our enum. And let's call it like, what should we call this one? So how many are there? Square root. Square root's literally the only one that differs. It has its own thing. So let's just call it FS. Or let's just call it S squared. This is just an identifier, so it doesn't really matter at the end of the day. And then here, Cloud hit you with the absolutely my apologies. Yeah, I knew it was like BSing me because I was like so confused. I was looking at the documentation, it was completely different from that, so I literally had to call it out. I had to call Cloud out. That's why we don't trust AI blindly like that. You're gonna end up with some type of error later down the line that you don't catch. And that was actually gonna be a big error too. If I didn't call it out, I might have to like rewrite a lot, to be honest. Alright, so f square root. No new logic is needed for this, so for all those stuff, so just implement it here. We'll do it here. I'll just copy this. For the most part, it's the same. And let's see how it changes. So as square root, we have a destination register, but no source register 2, so we can uninitialize that. And yeah, seems to be fine. Opcode's the same, right? Yeah, it's the same. The new leak is the best one so far. Yeah, I'll check it soon off stream or something. I'll let you know. Okay, let's move on. Well, first, we have to change the funct5. Funct5, that's gonna be 311, I believe. No, hex is different. It's not gonna be 11. A? No, A or B, something like that. Let's just check. I don't want to get it wrong. Hex is always weird. It was what, 01011? Oh yeah, it is B. Nice. I got it right. Where is it? It's this one, right? Yeah, it's this one. I just gotta change the name. Let's do the funct5, there's B, and change the name. Which will be... what will the name be? F square root, right? Yeah. Same right here. Or should I change the two names? I mean, I guess it's distinguishable by this anyway, so it won't really be a problem. I don't know if that's like an issue. I think it's fine. All right, let's move on. Or let's just implement square root first, and square root is like different from every other one. It has its own stuff, so let's just implement it so I don't get stuff mixed up. Yeah, so here it'll essentially be the same, except no rs2, so I'll just copy this. Just remove fs2. rs2, not fs2, sorry. And does it have rounding mode? Yes, it does have rounding mode. Yeah, it does. So we'll keep that there. And continue to move on. Oh yeah, here. And it looks like everything's fine now, so yeah. Now we can implement it in the actual thing here in our interpreter. Alright, so let's see how it's implemented. So computes the square root of rs1 and the result iterating to rd. So square root in C++, there might be a library. Why don't you switch? Oh, you might be right. It might be better to do a switch. Well, no, switch is the one here, right? So switch case, yeah. So depending on the name, I implement the logic for it. So I think this is right? I'm still pretty new to C++, so I'll take any advice I can get, to be honest. I'm only like a month and a half in C++, so still got a lot to learn. All right, square root in C++. Let's actually look. It's probably some library. Is there no better way? I'm sure there is, but I'm just not there yet, maybe. Like I know, instead of all these enum classes, I can do like a stud map and do key value pairs and like map them properly, but I'm not sure what like a better way for this would be, but I might learn something later. I'm not too worried about getting the right implementation on what to use the first time. The first write is always going to be pretty shitty. Like I just have to make sure the logic is right, and then I can rewrite later when I actually want to get something better. All right, let's look. C in the C math header. Okay, square root double, square root float. So I'm guessing we'd need square root for float. So let's take a look. Square root f turns the square root of a number type float. All right, so okay, so we need that at the top. I mean, I'm not gonna lie, the files are getting long, but it's fine for now. Figure it out. Alright, so implement CMath, and we will do the square root here. Let's see. So what is actually going on here? Float square root f float arg, okay. So you have two values. And we're just essentially setting the position to 12. I guess 12 zeros or 12 places, and then square root f for value 1. Yeah, we could do that. I'll probably make two variables here, so put value 1. What do you do other than coding? Like, what are your hobbies? Like, mostly I play games once in a while, watch TV shows on Netflix, also watch anime and stuff, and then hang out with friends, do random stuff in the day when I feel like it. But that's pretty much it. Alright, I guess we can store in value 1 and value 2. And we'll read the 1 register that we need the value from. Okay, I'll just call it value. We don't need 2 values because we don't need rs2. Anyways, last stream I saw you playing Grand Theft Auto. No, that was on stream. That was after stream. I went on GTA 5. Games like pretty much anything. Mostly like Geometry Dash. Not gonna lie, Geometry Dash has been something I've been playing a lot lately. GTA 5 once in a while, and then sometimes when like the boys hop on Fortnite or like Valorant, I get on that. Alright, so we're writing to a destination register and the float value, so we can store it. Oops, I forgot semicolon. Let's store it as a value. I guess we will call it value 2. Value 2 for the actual thing we're square root. Let's see. Oh yeah, and TV shows, I forgot. Like TV shows, anything in like DC, to be honest. DC or Marvel movies, DC shows on Netflix are there. Bunch of shows pretty much, like Stranger Things and all those like really common shows. One I need to watch is Breaking Bad, though. I've like heard too much about it, but I haven't ever watched it. Okay. I don't know why I'm getting confused about this, but it's just literally just implementing that, right? It will literally just be this. I assume, right? Yeah. Okay, I don't know why it took so long. Something's off. And what's going on here? Oh, yeah. There, that should be fine. Yeah, Breaking Bad is awesome. Yeah, I'll watch it someday. Start watching ASAP? Gotcha. Well, let's check this real quick. I'm missing out? Yeah, I don't know, maybe. Oh, yes, okay. I literally looked at it too, square root f. I just wrote it wrong. Claude is, yeah, me and Claude are like best friends and enemies, bro. He catches all my mistakes, but they're always silly mistakes, which like, yeah, that's fine. Stood. Oh, it's part of the standard library? I didn't even know. Yeah, I always put stood. For the namespace, proper namespace. Alright, that's fine for that. I feel like, yeah, these are like really silly mistakes. I feel like even like if you're into programming for like 20 plus years, you're still making silly mistakes like missing a semicolon or a break statement or something, so yeah, I'm not too worried about it. But that's the good thing about AI though, it can catch those very easily, those very trivial mistakes that could mess up a lot that you probably won't see yourself because you're not worried about it. That's the good thing about AI. Until it doesn't catch it, then it's a problem. But mostly it will catch it. Okay, that's fine for that. Now, This is gonna be a shorter stream today, but I'm actually getting like a good amount of viewers for this stream. Not gonna lie, like I'm up in like 7. I've seen the highest today was like 16, so I low-key gotta keep it going. I'm not tired or anything, so I can keep it going. All right, next is floating point minimum and maximum numbers. So this is essentially like the max functions that we probably need to use to grab the smaller or the larger. Yeah, I mean, it's starting to get easier for this part. I believe std max or something is probably there for that function. All right, yeah, let's go on with it. Before that, I want to see how many of these are the same. So these take in RD, RS1, RS2. It's just these two. And then this one changes, so we'll make a separate one for this. We'll call it fminmax. Because why not? That's a decent name. Most of these names probably won't stick around anyways. Once I implement the std map, that's gonna change. I'm gonna get rid of the enum class, but yeah. Fmin and fmax. Yeah, that's fine. And in our decoder as well. Oh wait, did I never add it in here? Okay, that's gonna be a problem. I didn't add it in here for the other one. Floating point. Square root, yeah, square root, sorry. Square root. We have to make this so it actually identifies what to return for our main file, because if we don't, then it won't know what to return at all. So we need to actually pass it in the string properly. So yeah, because it can't return like a struct like that. So, or the enum classification, not struct. That says square root fmin, and we'll also write fmin. Sorry, bro. I was speaking a different language. What do you mean? What do you mean by that? Okay, floating point in /max. I'm not gonna lie, at a certain point, as it gets like, if I know the logic, it starts to get pretty tedious. I'm not gonna lie, to just keep writing these instructions. Because when you're actually doing the logic, you're thinking about it, but after a certain point, when you're not thinking about it and it's like simple, like you're just kind of just going with it. So hopefully we get some new things soon. Alright, this is good. You call yourself a beginner, but you're clearly above average. Most beginners are making CPU emulators. I guess so. Like, I have like a year of experience in like Python. I guess that's why like my programming like brain is kind of activated. I don't know exactly. Like, I'm reading computer architecture and reading C++. I'm only about a month in on each, month and a half, and I'm just trying my best here to implement. I still get stuck a lot, not gonna lie. It's gonna ramp up really quick. So I wouldn't give myself all the flowers so far. But yeah, we're trying the best that we can. And then documenting this so I have like a footprint of all of what I've done. I think that's a good thing to do. I think everyone should start their YouTube channel and at least document some stuff. It'll be like a good thing for your resume. Alright, so I think we have all that. We need to implement the logic though. Not here, under the F squared, yeah. I will say if some like instruction systems programmer looks at the code I've written, he's probably gonna He's probably gonna cringe. Because it's pretty sloppy right now, but that's fine. I'll fix it later. Max is what we called it. And that takes in let's see. Forgot takes in RS1, RS2. And RD. We need our RD back. Oh, we already have that. We need RS2 back, sorry. We already had RD. We need an RS2 back. Alright, there we go. That's perfect. I'm gonna be back. I'm gonna watch a video. Alright, man. See you later. Yeah, that's fine. Opcode we need to change. No, not opcode. Opcode's the same, but func3. Opcode starts changing around here. Yeah, so I need that. Okay. Fmin, Fmax, func5 for this will be, that's 4 plus 1, 5. That's 0x5. Copy the same thing here. When are you gonna stop streaming? I probably don't plan on stopping streaming, because now I'm starting to get like a bit of traction, I guess, like in viewers. Like at the beginning I wasn't getting much, but now I'm actually like getting like decent. Like that actually makes me want to stream more, so probably won't stop streaming. I'll probably just, if this project ever gets done, like I'll just keep streaming for a different project. Oh, you mean for today? Oh, my bad. For today, I don't know. It's 12 a.m. but maybe like 30 more minutes. The one who got me to start streaming was this streamer called Kristen Codes. Like I watched his streams and I was like, I gotta start doing this. Love if you continue streaming. Appreciate it, man. Appreciate it. I know this can be like kind of a boring project to look at sometimes, because with stuff like front end or back end, you actually see stuff. Like you can actually test a lot and see stuff, but this is more so just me copying, pasting, and writing logic. So, but if you enjoy it, I appreciate that. All right, Fmax. That func5 will be. It's the same. Oh, it's the same. Wait. Oh, but the rounding mode is different. Oh, okay. Wait a minute. Yeah, this project's more about correcting this than flashy stuff. Yeah, definitely. It's gonna get really hard though. Like the chapter I'm reading right now, it's about pipelining, which I don't fully understand, but that's the next implementation after I do floating point and double. But I'm kind of excited to see where this project goes, to be honest. Okay, so it's the same, but the rounding mode's different, so I don't really know how to access. We don't have, like, we never made an identifier for rounding mode. Should we have made an identifier for rounding mode? Let's see. Let me ask Claude. It'd probably be better if I just screenshot. Difference is mainly it's only the rounding mode. So my normal way of well, I guess we kind of did. It'd essentially just be I think, wait, actually, hold up. I kind of thought of the solution while querying, but I think we can just... This occupies the same bits as our funct3 in order places. It's just bits 12 to 14. So I think we can just use a function for funct3. That's why we didn't make it like that. So the funct5 is going to be the same, but then we'll do an and funct3. So this is where funct3 will be useful. Are we on GitHub? Yeah, it's in the description. This project's on GitHub, and a couple of my other projects, but yeah, it's on GitHub in the description of this live stream. Yeah, so yeah. Claude, I don't need you anymore. Yeah, so this one's gonna be 0x0, and this one's gonna be 0x1. 0x1 for max, and 0x0 for min. And make sure to change it. And it's essentially the same. Okay. Now implement it in the interpreter for registers. Okay. I also did upload a video the other day, like actual long form video of my project so far on YouTube. And basically explained, not like in depth, I can always go in depth on everything I've done. Like if someone wants me to go over like all the logic for all these bit shifts, I can do that. I can make a video on that for sure. I understand it well enough to the point where it won't be like a Dunning-Kruger type tutorial. I actually know what I'm doing for that part, so I could definitely do that if people ask. Okay, so we have rs1, no, not rs1. Let's see, let's go back. So fmin, so it's essentially just taking those two values again. Now we're gonna do the second value, so let's actually distinguish value 1, value 2. So rs2. Okay, this one, we wouldn't need this anymore, so let's see what we actually would need. We need a min-max function, so let's actually go take a look at what min-max is. Oh, it's literally just called student min-max. I'm not gonna lie, I don't get some of these implementations on that. I'm gonna go to Geeks for Geeks instead. Okay, it's defined an algorithm header file, so we can include that at the top. Algorithm, and we'll keep going down here. All right, so for fmin, and I believe that's also in the standard library, so we need std min-max. Okay, that's very simple. Std min-max. Wait. Oh, okay. I understand. Okay. So accessing that dot first gets the maximum, or the minimum, sorry, and then dot second is the maximum value. Interesting. Okay, yeah, that makes sense. So yeah, value 1, value 2. Wait, no. Because we actually need to access the minimum value, so we need to actually like access it properly. Why is it not allowing me to do that? Did I do something wrong? Oh, we need to declare pair to catch the return value first. So in our case, we're doing pair of floats. I'm guessing std pair. Float and float. So we're taking the two float values, and we want to call it just min. And then here, since we already declared min, we can do min equals std min max value 1, value 2. I forgot about that. Alright, yeah, that makes sense. I'm gonna low-key put some spaces in this so it doesn't look so cluttered. And then we want to access min dot first. I think that's the right implementation. Let's also do the one for max, and we can check. You can check it. Fmax. So Fmax. One thing I kind of realized is this project is starting to get like simpler for me to think about. Like at the beginning I was kind of struggling, I'm not gonna lie. Not too much struggling, but it's like a little bit. I'll admit I was struggling a little bit to actually understand like the nuances of the project. But now I'm actually starting to kind of be on a roll, not gonna lie. But let's not say that too fast though. It's gonna get harder soon. In this case, in that second. Yeah, I think that's fine. And we'll show Claude. Did I show Claude my square root function? Yeah, I did. Show Claude my min and max function too. And also show my implementation here as well. I forgot the break statement. Then I forgot the break statement. No, I got it. Never mind. Okay, I got it. Okay, making sure. I didn't write it because I copied it, so I thought I missed it. But okay, let's see what's wrong. All right. Std f min f extra simpler using std min max works. CMath already has std f min f max. I forgot to change it. Okay. So there's a better implementation. And this will cover IEEE 754, which is what I want. I don't want anything to go out of that, so. Okay, I kind of want to know what's the problem with using min-max, though. I'm just curious. Is a problem with using... Is there a reason it's different? edge cases. It's different how they handle NaN, not a number. Okay, that's significant then. I don't want to... If they're not handling NaN properly, I don't want to be using that. Okay. Okay, thank you, Claude, for pointing that out. So we're not going to use did min max because we'll run into problems later. We want the spec behavior for the floats to actually match, so we don't want to do this. So I will get rid of this. But it was a nice try on the implementation. I always like implementing stuff first before querying, but sometimes that backfires. So what was the library called? Did fmin instead fmax. Okay. So we don't need all this stuff there. So essentially just be std fmin and two values. Right? Am I doing something wrong? Oh, I always forget, dude. The parentheses is always a problem. Alright, that's fine. And then do the same thing here and just change it. Yeah, let's change this. Not std min max, get rid of that. Just change this to fmax. Fmax is the right one, right? Yeah, okay. Interesting. Oh, he wrote it right here. I need to read more, bro. He literally wrote the edge case here, and I asked him why the edge case doesn't work. I need to read properly. Alright. That's fine. We got that sorted out. We got that edge case sorted out, and... okay, case instruction. Yeah, we're fine here. We got those, and let's see. What's next? I'll do a couple more. We're low-key on a roll, so I can do a couple more. Alright, let's see. What changes here? So we have fm add. What does fm mean? Let me get some water real quick. Yeah, I'll be back in a second. Let me get water. My bottle's empty. Alright, I'm back now. Alright, let's do it. fm.s is a single precision fused multiply addition. Interesting. Wow, okay, that's interesting. So we're fusing multiplication and addition together. So first we're adding the source register 1 and source register 2, and that we're multiplying and then adding register 3. If it follows like the whole PEMDAS stuff, like precedence, it'll do that times that plus that, which it should. I don't see why it wouldn't, so that's fine. And yeah, we can try and implement that. Let's just look at the opcode and stuff. So fm.add, fmadd.s, fmsub.s, they have a different opcode from everything else, so that's different. Oh, okay, so RS3 is what takes the top 5 bits now. That's significant. So is it solely... Then what distinguishes it? What distinguishes these two? Is it like just a rounding mode? Let me see. Interesting. What is the way to distinguish these two? Oh wait, no, I'm done. They're a different opcode for each one. Okay, that makes it simpler. I thought I was gonna have to write something for that. Yeah, let's do it. Alright. So these ones will have their own thing because they're different formats, so they're gonna have their different part. So it's gonna be this. This is also the same. RD, RS1, RS2, RS3, RM. Yeah, so that's fine. They're all the same, essentially the same, until this part, the convert part. So what will we call these? Let's think of a good name. So we have, these are multiplication addition, fused, fused. Interesting. These are kind of weird ones. I'll have the negative value. Oh, we have to do sign extension? Okay. This is quite the implementation for this stuff. This is gonna take not a long time, but it's gonna take a bit, so... Not gonna lie, I might just end it here. How long have you been streaming? Hour and 38? Yeah, I think I'm gonna call it here. We'll continue tomorrow. We'll see you guys. I appreciate all of you for being here. I think we peaked at a good number today.